Today I will do the find leaves of binary tree. Given a binary tree, collect a tree nodes as if you were doing this. Collect and remove all leaves. Repeat until the tree is empty, right? So what we can do is, let's say if we have the tree like 1, 2, 3, 4, 5, and the result we need to be the leaf 4, 5, 3. So we return on the leaf. After that we return the second leaf, right? Is a After we remove this one, we have 1 and 2, and the 2 is the second leaf, and then 1 becomes the leaf node, right? So okay, got it. So uh, for the G, for the DBS, if we want to get the leaf first, so we have the in order, right? Post, pre-order, and post order, right? So in order means that we have left, root, and right. Pre-order means we have root and left and right, and post order we have left, right, and root. So in this case, if you see here, I can say we need to do the post order, right? So the first observation is we can do post order, right? So now the question is, when we move the post order, we say for, I say is when we will stop loop again. So we say if it's a for, then do we go to the child of this, mean none and none here, right? So let's say if this one is none and left side and right side. So okay, we can do like this. We will go from one I go 2 and 3 first, right? 2 I will go to 4 and 5 first, and 4 is a leaf node, so I put it into the response, right? And then 5 is a leaf node, I also put it into the response. Now go to 3. 3 is a leaf node, I also put it into the rest. But 2 and 1 is not. So now we need to delete, right? Right. So what I can say is, so now after I delete this one to none, 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 if we find the leaf node, what we will do? So if it's a leaf node, I add it into the result and I set it into none, right? Right. So and then I will continue for the remaining. Remaining mean I have 1 and 2, so I remaining. So we can do the post order to find the leaf node, right? And when we found leaf node, we can do is add leaf node to current response, right? And then set leaf node become so then we will set the leaf node become none, right? So and then after that for this traverse, right? For this remove, if the root is still none, then continue with until root is none, right? So yeah, so I will continue doing it until it's none. So I can say I have the list of integer, right? And here is the result, right? So firstly I check first if the root equal none, right? Then what I do is return the new array list of this integer, right? Immediately. So I just return the blank. So now we know the list is not none. So how we can do it, right? So we can say while root is not none. Then what I do is first, when we go to this one means that we are going to remove on the leaf node. We will have the leaf node, right? So we will need to have the list of integer, right? So here is the leaf, right? And then this leaf you will need to new array it, right? So you can have the leaf node. So then here you remove. So here will be post order remove leaf node, right? So I just put it here, and we need to write another method, right? So I can say I have the post order remove leaf, right? So I put the G node here, and it is node, right? Right, and then I also put so I also put list of the integer, right? It is a list, right? So now you see when we will stop this traverse, right? So 1, I go to 2 and 3, 2, because I have child, I go to 4 and 5. When I will stop it, if node the left, if node the left equal none, and node the right equal none. So I know that, okay, here is a leaf node, right? So if that one is a leaf node, what I do here is I added it into the leaves, right? And then I set this node equal to, right? Right, I can set the node equal to, and then I return, right? I stop doing. Now it come here, then it is not the leaf, right? So when you say you are not a leaf, so what you will do, you will just like post order this one, right? So I will just post order this leaf node to the node left, right? If node left, right, none, then I will do it first, right? And then if node right, not none, then I also will remove on the right. And then what I will do is I just keep the node, right? I just don't do anything. I just do it left and right first. And because I set the node become none, mean that the parent, right? The parent map to this one will be none, right? Okay, wait for me 1 minute. I think we can return the so how to remove the one? Okay, I think here we can put the G node, right? So for example, I want to return that node, right? I can just say node the left equal this, and I will add this one into here, and I say return none, right? So I remove this, and then in my here I say node the left, right, equal with this return, right? I remove left, so then I will, if it remove left and if the one is none, it will return none. If not, even like for example here, if I remove in 1, I will have 2 return back, right? 2 is still okay because I just remove the 2. So for example, I'm at 2, I will remove the left, and it return none here. To the left is none, so I just like set it to none, right? Let's see where the node, no, this one we need, let's see node equal none work or not, right? So I will comment this one first. I hope note the left none works, so we don't need to do anything. So just do this, right? And then after that we will have the leaf, right? So we have post order of root and leaves, right? And after that, rest the add the leaf, right? As I understand, right? After this, I just return the rest result, right? Let's run. Any error? Leave at node, leave, or I can say node.var. Okay, I think wrong. Sorry about it. So this one, because I put it need to be void. So if node.left is not none, pause order and then we need to put list and list. Okay, right. Time limit exists. Why? So if the time limit exists, means that let me run. If time limit exists, means that somehow our looping here is not really correct. So let me check again. So for example, we have 1, 2, 3, 4, 5, and you see if we add the node again, then we just stop that one, right? Node equal none, and then we stop. Then if the node come here, so for example at 1, I think because why root not none, so you can keep run that one forever, right? But we actually need to update the root again. So let me think if so for example 1 here, I have it not none, I will go to 2 and I go to this one, right? And then I remove it. So I remove all the, if run this, what I do is I go to the post order remove leaf and I remove so I have root, right? Root is a different with this one. I remove in left in 2 and I also remove in right is a 3. So let's say I remove 2. 2 is not the root as a leaf node, so I remove in 4 and I remove in 5. When I remove in 5, let's say because 4 have the right and left is a none, so I add it into the leaf and I set 4 equal none, right? And then I just stop. Okay, got it. And then again here I also do that one, I set it none. But to be honest, I think the root is still doesn't here, just like the reference of the code, but it doesn't. So okay, I get it. So I can say here is a chino. So you can think in Java we have the object and reference. The node equal none here is just is a point that reference node to another object, but actually the real one of the root still 1, 2, 3, 4, 5, and then it makes the root never become none, right? So let me say if like that, I just put it and I put into none, correct? And then I say node the left, so I will say node the left equals this and node dot right equal this, and then I return node. So let's say what happened if node is so what happened if we remove 4, 5, 3 and now I remove 2, right? So now I have only 1 and 2. So 1 and 2 once not the leaf, so I go here, so we remove 2, we will return none, then 1 becomes a leaf. So now come here, 1 is a leaf, so I just return. So what I do here, I need to be root equals this one, right? So let's run it. Let's run it. So you see here we correctly, right? So in Java the reference and and the object, in Java the reference and the object is not always is a complex one. We need to be carefully to handle it. So let me submit to see any X case, right? Okay, we are good. We passed 100% of the Java Online. So I will stop that record here, right?